I just got this working. Let's see if it works. That was 27 minutes ago. What about now?
On our end, it says it's live streaming now.
Where does it say that?
On my screen, when you started doing it, it says this meeting is being live streamed, so I assume it's working.
I just got this working. Let's see if it works. Okay, it's working. There it is. A little behind me. Okay, it'll be here on my live stream list as soon as it can be there. Okay. All right, so I'm just going to shut those down. Keep that open. All right. Let's start with what I need to go over today. Okay. Agenda mod 4. Okay, so homework 3. Okay, homework 3 had the product rule, the quotient rule, the chain rule, and transcendentals in it. Are there any questions from homework 3? Let me just get into your class.
I actually have a question about the quiz. Which quiz is due today? Quiz 2 or quiz 3?
3.
Got it. Thank you.
So were there any questions with homework 3? Or I'll look, okay, let's look at quiz 3. Hold on, item analysis. Okay. Okay, so
Professor, can you share your screen? We can't see it.
oh yeah, because when I do that, hold on, I can do it now. Can you see it now?
Yes, thank you.
Okay, so this is the item analysis for quiz 3. It says use the Desmos link to find these things. Give the answers. Don't forget the units. Cases per month. So all right. So if I click on, so it looks like they want f of 2, f prime of 2, and f double prime of 2. So if I click on this, I see some data. If I want f of 2, I could just go like this. F of 2 is going to be, looks like somewhere around 2. No, it's around 350. 2 and 350. That's probably right. But how are you going to get the derivative and stuff? You're going to get the derivative. Well, you might go to this table and put in 2. And that'll give you the derivative. But how do you get the second derivative? How do you get f double prime? Well, you could just type in f double prime of 2. So it's minus 125. Or you could just take the screen and enlarge it. And there it is. Okay. No questions on that? So it's 350, 329, minus 125.
I got that answer correctly, but that's wrong.
Did you write cases per month, and cases per month per month?
No, I don't know.
So the first answer, the 350 is going to be cases. It has to be exactly like that. Maybe even capitals, I'm not sure. Then 329 was the second one. 329 is closest whole number. It says to do it as whole numbers, give as whole numbers. So you say 329, then you have to say cases per month. Okay. And then the next one is minus 125 cases per month per month. If you put anything different, you put 2 spaces in between the cases, space per, it'll mark it wrong. So you have to write it exactly that way. Okay, if you get frustrated and you think you got it right, then talk to me after class and I'll take a look at your particular question and see why you missed it. Okay, any questions on this before I move on to the next one? Okay. Well, this is the same thing, but with a 3.5, so. Again, all I have to do is put in 3.5 here. And there's the answer, 667,114 and minus 50. But again, cases per month, cases per month per month. Okay, next one. This is the exact same one. Only now you put in 4.4. Okay, so here's one we have to look at lines 2 and 3 and tell me what happened. What happened in lines 2 and 3? Okay, it looks like they just took a derivative, right? I see maybe they used a chain, they used a power rule and a chain rule, but they did a derivative. Does anyone remember what S means? S of t is not like f of x, it's a something. It means something. So let's see what we got here as possible answers. Okay. So you won't see any that say there's a derivative of, so the chain rule and the power rule. Well, that was certainly used, the chain rule and the power rule. I feel badly because this marked it wrong, but it was actually the position, S of t is the position function to find the velocity. But there was a chain rule and a power rule used. There was no product rule or quotient rule. There was no natural exponent. There was no derivative. There was no mean value theorem discussed. It was just plain. There's a power rule and there's a chain rule. So I see why it was missed, but this is when you take S prime, that's velocity. Okay. All right. Here's a lot. Questions 8 and 9. What happened here? They took the derivative of y. And what did they do? Anyone? Anyone besides me?
Use the chain rule and the
No chain rule.
product rule? Or just chain rule?
Just product rule, no chain rule.
Oh, just
Because
product, okay.
second times the derivative of the first plus the first times derivative of the second. There's no there is no powers or anything being done because they haven't. Right here would be the chain, would be the power rule, and here would just be no. There's just a power rule, no chain rule. Okay, so for this particular one, it's just the product rule. So it's just the product rule. There is no chain or power rule being done. There would be a power rule coming up, but not at this point. It's just the product rule. Okay.
For lines 5 and 6, it's using the chain rule and the power rule, right?
Yeah, this is definitely the chain rule and the power rule because they changed this to a power. So it's the minus 1/2 power. So then they subtract 1 and then take the, oh, yeah. So the power rule is right here and the chain rule is right there. So yeah, this is power and chain. Okay. That answer your question, Alicia?
Yes, thank you.
That's not one of the ones people missed yet. Find the derivative. How do we find the derivative here? We break the derivative. Remember, oh, what's that? Hold on. So what we do is, we take the power down, we take the derivative of the outside, so that's 9 times 3 is going to give you 27. And it's a power rule, so you subtract 1 from 9 is 8. What do you do with this inside stuff? What do you do with it? What do I do with the inside stuff? And it's just as a chain rule, there's a function inside another function. So I just did derivative of the outside to get the 27 today. But what do I do with the inside?
Keep it the same, huh?
I keep it the same. I have a choice. I can either leave it the same or I can take the derivative of it. In this case, I leave it the same. And then what do I have to do? Then I have to multiply.
Find the derivative of it.
Right, which is what, 6x to the 5th plus 1. Okay? And you should, the hint to this is the fact that it's asking you for a something in parentheses raised to a power. Here's a something in parentheses raised to a power, and then they're saying more. So that's your hint that there's more here. Okay?
Wait, how did you get the 8? Sorry.
I subtract the power. The power rule says bring the 9 down and take 1 from it. So this is 9 minus 1. The power rule says you bring the n down, so it becomes nx to the n minus 1. Okay, but since there was a 3 already there, it's going to be 3 times n. That'll give you 27. That's the 27 right there, 3n. The power is n minus 1. That's 9 minus 1. That's 8. And then the x you'll leave alone. And then you take the derivative of it. Okay? Does that help, Alicia?
Yes,
you.
thank you.
Okay. So that's the answers right here. 27 for A. B is going to be x to the 6th plus x plus 14. X to the 6th plus x plus 14. C is going to be 8. 8. And then the last one is 6x to the 5th plus 1. Okay. Interesting question. What's the derivative of 3e to the something? What's the derivative of e to the something? Derivative of e to the x. The derivative of e to the x. Anyone? It's the derivative of e to the x. What's the screen that I'm sharing? Hold on. For some reason I'm stuck in this. Okay, there we go. It's derivative of e to the x. Anybody? You know I'm
Is
gonna
it
add.
is it just e to the x?
It is Aiden. Thank you. Derivative of e to the x is e to the x. What is the derivative of e to something? But there's a function on the inside.
It's 15 e to the power of 5x plus 1.
Right. So you're saying is the derivative of e to the x is e to the x. But if you have some function in there like y, then it's going to be, you leave the y alone, and then you have to multiply it by the derivative of the y. So what's the derivative of 5x plus 1? That's 5. The 3 still, if there's a 3 there, it doesn't really matter. It's out front. So now you have 3e to the 5x plus 1 times 5. So now you can take the 3 times the 5 and make it 15, like Eric just said. Any questions on that? Okay, that's what it says. So 15e to the, so there's 15e to the 5x plus 1. Okay. Fine. And that's the end of them. These, after that, they're 75% is fine. Okay. Any questions on that? Okay, back to my agenda. So we did the homework. So you saw product rule, you saw quotient rule, you saw chain rule, and you might have seen some transcendentals. Right, so now let's take a look at your derivative stuff. Under lesson, mod 3, derivatives. Sebastian. Your topic is about what?
Growth population.
Potency months? Okay. Good, I'd see that, that's good. Okay, so which one of these times are you going to be looking at? 1, 2, 3, 4, 5, do you remember?
I think we looked at either 1 or 5.
104 or 99 and minus 1.2. Okay, fine. All right. Out here. Okay, so it's just you and Aiden?
Yeah, everybody else is on one.
Aiden, can you tell me what you wrote here? And remember, you're talking to your mother.
Yes. According to the exponential regression, after 5 months, the drug potency is 99 mcg per cc, dropping by 1.2 micrograms per cc per month, and the drug potency is decelerating by 0.015 micrograms per cc per month per month.
Okay.
Might be a little wordy for my mom.
Probably. It's okay. Here's the thing. Does everyone understand that it's dropping by 1.2 at 5 months? It's dropping by 1.2. So between 5 months and 6 months, you think it should drop by 1.2, right? Because it's dropping by 1.2 a month. So if it was 99, it will be 97.8. Okay? It would be, except that's assuming that it's dropping consistently throughout the whole time. Okay? Do you understand? If I'm here and I'm going 60 miles an hour for the next hour, then I go 60 miles, right? That's what 1.2 is. It's a rate saying how fast it's changing per month. For 1 month, it goes up by 1.2, except it's decelerating. What does decelerating mean? If I'm going 60 miles an hour and I decelerate on my way home, am I going to make it home if I'm going 60 miles an hour for an hour, but I decelerate? You don't know how far I'm going to get because I could be decelerating by quite a bit. Okay, I could take my foot off the gas entirely, decelerate to 0. In which case, I'm just sitting there and I'm never going to make it home. In this case, it's decelerating by 0.15. So that speed that's 1.2 is dropping by 0.15 every month. That's what it means by the rate is 1.2 micrograms per cc per month. But it's that number is dropping by 0.015 micrograms PC per month each month. Okay, so the next month it should be dropping by not 1.2, but 1.185. All right. I'm just trying to get you to think about these things. That's where we're heading. That's why it says per month per month. Okay, Cody, are you here? Cody. I haven't seen Cody in a long time. Hello. I see Aiden, Eric, Alicia, Jonathan, Carlos, Luke, Acacia, Havani. But I don't see Cody. But you're talking about hours studying in your grade. Okay, so I see 12, 14, and 24. So Acacia, oh, Jonathan's recorded a video. Let's see what Jonathan.
According to the Gordon regression, after 12 hours of studying, we would have achieved a grade of 75%. And by studying for 13 hours, the grade will increase to approximately 79%.
You read what you wrote, but I'm not excited about it.
It should have been exponential, right?
No. You have a quartic regression here. the Sebastian and Aiden have the exponential because they liked it. Yours is quartic. But which one are you doing? 12 hours? So look, 12 hours of studying at 75. At 12 hours of studying, you get a grade of 75, right?
Right.
And it's increasing by 4% an hour. So just say that. It's increasing by 4%. So in 13 hours, yes, it would be 79. But that's not what I want you to say. I want you to say it's increasing by 4% an hour. And I want you to say it's decelerating. That's a negative. So it's decelerating by 0.7 per hour.
Okay, I can fix that.
Fix up, but do you understand what I'm saying? Is so like it's at 12 hours, here's 12. Bloop. Right here, the slope of the tangent line is about 4. That's the slope of that line. Right there. Bloop. But you see, as you get to the next hour, it's actually going down by a bit. It's not 4 anymore. It's now lost 0.7 of that. So now what's the slope now? Now the slope after an hour will be 3.3. Okay. See, so at one point it was 4, and then the next hour it's 3.3. That's what it means to decelerate. It was going faster and now it's going slower.
Okay, yeah, that makes sense.
All right. Uh-oh. I have no idea what I just did. Did I stop sharing? So there we go. I'm still sharing and I'm still doing that. And let's close this. And move on to the next one. That's just Cody and Acacia and Jonathan. Do you have somebody else in your group that didn't do anything? I know you do.
We haven't heard from him in a while, so we don't even remember who it was.
I think his name was Dylan or something. I'm not sure.
Oh, so it's just the 3 of you? Okay. All right. Slade. What you talking about today? This is your best friends and your salary? Yeah. So you have a salary of 75 and a salary of 100. Person who's making 75 has 2.3 friends. A person whose salary of 100 is got almost 5 friends. But as they make more money, they're also both making about 1/10 of a friend more each with each $1,000. With each $1,000, they pick up 1/10 of a friend. So if your salary is 75,000 and you go to 76,000, you should pick up 1/10 of a friend. Okay, but it's for 75, it's accelerating, so it'll actually pick up more each time. And for 100, it's decelerating. So you're gonna, but they're really close to 0. So honestly, they're not changing much at all. Okay, so let's see who said Slade. Who's in your group? Selena. Selena's not here. Oh, I really want to answer that call. Really want to answer that call. Okay, Selena. She wrote, according to the report, Selena's not here. Did somebody read anything from your group? Rudra. Okay, so actually you can both read them. Rudra, what does yours say?
F of 35 equals 2.3 to 3 to 4 BFF and F dash of
Prime.
Right?
Not F dash, F prime.
F prime F prime of 75 equals to 0.11 BFF per $1,000 and F double prime of 75 equals to 0.0014 BFF per $1,000
Right, so every time it goes up $1,000, the rate is going up by that many per $1,000. Okay, good. Selena, it's not here. You want to read her? Is she here?
Yeah.
Refresh what? What's going to be here?
Audio, speak.
No, it's going to kick me out. You knew it would kick me out. just wanted to make fun of me. Derivatives, is this it? Slade. Selena. Car, so what did you say, Car?
F of 75 is equal to 2.324 BFF. F dash of 75 is equal to 0.11 BFF per $1,000. F double dash of 75
prime.
is 0.0014 BFF per $1,000.
Okay, now who's gonna read what Selena wrote? Somebody?
According to the party impression, when our salary reaches 75,000, we would have gained 2 BFFs, and by the time our salary reaches 100,000, our BFFs number will increase to 4 BFFs. Last time you said, this was limits, but she wasn't here.
No, but this is not, I don't know what she's doing, but this is,
She wasn't in the class last time. She wasn't. So she just submitted.
yeah. And this is not right.
Yeah.
You're not gonna lose points for it. She's gonna lose points though, because this is wrong. And it's not wrong, it's just not, yeah, she's just talking about 75 and 100, but we're done with that. We're talking about how fast is it changing at 75 or 100?
Yeah.
How fast is it changing at 75? It's changing by, it's 0.11 BFFs per $1,000. And it's,
$1,000 per $1,000.
I would just say accelerating. Yeah, that's too tiny a number. Accelerating by a little bit, because this is your mother. You're talking to your mother, not talking to me. And when you're reading this out, you're saying, I got a couple, I make $75,000. I got a couple of friends. And I expect if I make another 10,000, maybe I'll make one more friend. And it's kind of accelerating. Good for me. Not really, because then when you get to 100,000, it starts to decelerate. So you're increasing by even fewer friends and it's slowing down. Okay. That's what it says. All right, so you want to make sure for this one that you have to talk, that's what she did wrong. She didn't talk about how it's changing. She took a chunk, that's like an average rate of change. I don't care about 75 to 100. I care about what's happening at 75. That's my salary. I want to know, am I going to get any new friends? I'm getting 1/10 of a friend, which isn't going to amount to much. That's why I say I have to make $10,000 more to pick up a friend. But that's the rate at which it's growing. That's the rate at which my friends are increasing. Okay, come on, what's going on here? Next post. Alicia, are you here?
Yes,
Alicia?
I am.
Look, she's world population and she put her link right there. And I got Pamela right here. And I've got Pavani on the line. She's here. So let's see what Pavani has to say.
According to the Quartic regression, after the year 2010, the world population would be 6.8 billion, increasing by a rate of 59 million per year and decelerating by 2.9 million per year.
What's wrong? What did you miss, Pavani?
Wait, no.
Per year at the end, at the very end. It's per year.
Oh, my bad.
So I had to
Sorry.
record all the, but I have to say, can I just say, sounds smart. That's she's,
According to the
am I-
Quartic regression,
am I not watching like some sort of a YouTube, not YouTube, a documentary on world population? You sound really good, Pavani. This sounds very professional and you sound smart. What? The closed captioning and everything. You should have put a video on there. And you could have been looking smart when you're saying it, like, according to this regression. Anyway, but it sounds good. Except you have to do per year at the end. Okay? Very nice. These are supposed to make you sound smart. Really, that would be, if there was one thing I wanted you to do was sound smart, that would be a huge accomplishment. Just to sound smart. I'm telling you, calculus scares people. It's while you're thinking it's scaring you, you'll eventually figure it out and it won't be so scary. But other people who have not taken it are scared by it. Okay. So that's the end of those. They were very nice. Class questions, where are they? They are. Hold on. Class questions are. Okay, so mod 4. Oh, mod 4 isn't open yet. I'm so sorry. I did not make it open. So now it's open. Woohoo. Now in mod 4, I'm going to ask Rudra, what is calculus?
Is the language and study of change.
No, math is a language.
Math is
Calculus
language and
is a type of language. It's the study of change. Sebastian, what is changing? I'll take broader answers. I'll take out sort of answers at this point. Pamela, you're next. What is pre-calculus? No, that's calculus. What's pre-calculus? Study of, what's f of x?
Rate of change.
No. What's f of x? Does that mean? Why do we use the letter f?
Function.
Okay, so Sebastian, what's changing? Functions. That was not great. Don't do that to me again. I'll take the points. Pamela. What are the two rates of change? Average and instantaneous. How many points do we need for the average rate of change, Jonathan?
2.
Okay, why did we invent limits, Palani?
Wait, I don't know. I can't find that question sheet.
Can't find the questions. Why did we invent limits? I ask that all the time. Hold on. I can't leave from the screen, but I might be able to. All right, so mod 4. Well, you in mod 4 and it's not in mod 4 because it should be in mod 4.
It's in mod 2 as well, I think.
Let's see. I'm going to check mod 4. Is it in questions mod 4? Why? Okay, so why did we invent limits? Is that the question I'm asking?
Yeah.
Why did we invent limits? Right there on the screen. Just read it out loud.
To take the 2 points of 5 to the 1 point of IRC.
No, you have to say what ARC and IRC mean.
Or the average rate of change to the 1 point of the instantaneous rate of change.
That's what we did. That's why we invented it. All right, fine. What happened to I had a thing here and now it's gone. Oh, here it is. Okay. Alicia, what do we need for continuity? Oh, what do we need for continuity?
The function needs to exist, the limit needs to exist, and the function limit needs to exist.
Function equals the limit. They have to equal each other.
Function equals the limit. Okay.
Okay, good. Luke, what are the other ways of saying instantaneous rate of change?
The derivative or slope of the tangent line.
Mm-hmm. Derivative, slope of the tangent line. Some more.
Velocity or dy dx.
Yep. That's it. Very good. Sleep. What's the derivative of a constant? 0. Acacia. What's the derivative of x to the nth power?
First, I don't know. I've never seen that question before.
Yes, you have its power rule. I just went over it before. X to the n. Who asked me this? Who asked me where that 8 came from? Acacia, was it you? Who asked me where the 8 came from when you had?
Oh, that was me.
Alicia, what rule was that?
That was the product rule.
Product.
Oh, forgot already.
The power rule.
Oh, the power rule, the power rule.
That's what it is. You brought the N down. What
I
did we-
mixed it up because it was a mix of both of them.
Okay, so Acacia, back to the power rule. Look it up. Look at the thing.
N times x to the n minus 1.
That's it. That's the power rule. Thank you. Cody is not here. Is Cody still not here? Cody. Eric, what does the quotient rule say? Quotient rule? Eric? Quotient rule, Eric. Did Eric leave? Oh, you're there. What's a quotient rule? You have a numerator and a denominator, or a low and a high, or a bottom and the top. It's the no quotient rule. I have to keep asking it. Can't you just find it in the answers? Is it in the answers? Yeah, so what's taking you so long, Eric? Just read it for the answers. You guys are killing me here. That's why I give you the answers so that goes fast. Otherwise, I'm gonna spend all day. So read that. The next time, don't make me open this up. So I'm gonna start taking points off. Go on, read it. Read it and weep. Eric, can you read line 35 out loud? I can't hear you. I'm starting to lose my patience, and I don't lose my patience easy. Can anyone else read it for me?
Yeah.
Thank you, Shane.
Denominator times derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared.
That's it. Thank you. All right. Who's next on my list here? Aiden, what's the derivative for e to the x and natural log of x?
Derivative of e to the x is e to the x.
And natural log of x?
And the derivative of natural log of x is 1 over negative x. Or 1 over x.
1 over x, or x to the negative 1. Very good. Selena's not here still. Slade, does the chain rule say? Slade, did I ask you a question already?
Yeah.
Oh, well, then I'm not going to ask you this one. Garth, what's the relationship between position, velocity, and acceleration? Ooh.
The rate of change of position over time.
Okay, is what?
Rate of change of-
Velocity is another word for a derivative. It's derivative of the position. And so what's acceleration? Remember, you saw two little primes. What was that?
Right.
Second derivative. Yeah, so velocity is the first derivative and acceleration is the second derivative. That's just the intro to what we're doing today. Okay. That's where we're going. Well, we're not going to do it today. Probably we're going to do it next time. All right. Where else? Where's my notes? Okay. So what are we going to do today? With the class questions. So today, or this week, this module, what's contained in this thing is implicit differentiation, hyperbolics, Newton's method, acceleration, and higher order derivatives. Okay, so what are these things? So let me just say there's a few things going on here. Higher order derivatives are just, they're going to be derivatives, but second derivative, third derivative, fourth derivative. That's higher derivatives. I don't think we're going to get to them today. Newton's method and implicit differentiation, these are applications of derivatives. Okay, there are ways of finding derivatives in situations, there are ways of finding things. Newton's method finds zeros, which means Newton's method used to solve equations. Okay, and implicit differentiation is a way of finding derivatives when a function isn't explicit. Okay, and hyperbolics, that's a whole different category. That's just new functions. So a whole bunch of new functions, transcendental functions that just come out in this course. They could have been in pre-calculus, but you had a lot of stuff to do in pre-calculus, so they decided to throw it in calculus. But lucky for you, it really doesn't have any applications until multivariable calculus, which is Calc 3. And by then, everyone who's in any Calc 1 class will have forgotten that they were even mentioned. Because I know, because I taught Calc 3, and I was like, do you remember these things? And everyone says no. Okay, so I will ask you 1 or 2 simple things about hyperbolic trig function. Okay. I don't have any speaking out stuff. So the 2 things we're going to be doing with talking out loud, it's going to be hyperbolics and higher order derivatives, but I don't have that slide ready yet. So to wait till next time. All right. So let's review what we did last time. Remember, we did the definition of the slope of the tangent line. Remember that? That was the definition, and then there was different notations for it. Okay, and then there was the equation of the tangent line. Okay, for equation of the tangent line, you can write it this way. And what we're writing is the derivative times x minus a plus the function evaluated at a. Okay. And remember, we had quick and dirty rules, derivative of a constant, all of these things. There's the sum rule, there's the, if you have a number in front, there's the power rule, there's the product rule, there's the quotient rule. Those are all things that we've done so far. Derivatives are transcendentals, e to the x natural log of x sine, cosine, tangent, all transcendentals. By the way, tangent, yeah. You need to know derivative of sine and derivative of cosine. Okay, we also did the chain rule. The chain rule was about when you have a function inside another function. So you did g of x inside of f of x. And if you do that, if you're taking the derivative of a function inside another function, you take the derivative of the outside, leave the inside alone, and then multiply it by the derivative of the inside. I was trying to think how this makes sense. So this is a composite function, which means it's an assembly line. And a derivative is how fast something is changing. And if you have an input and you process, so let's say you're given things a certain way, and you have, let's say you get stuff and it takes you a certain amount of time to do your job. So you're given something and it takes you a certain amount of time to do that job. Well, that would be like the derivative of you doing your job, right? That's just how much you're changing. But now if you're passing it to somebody else, so you're doing your job and you're producing a certain amount. So this is what the amount you're producing. Then that person who's getting the next thing in line, their rate is going to depend on how they process stuff, depending on how you give it to them. Okay, so you're giving it to somebody and they're processing it. And that's how fast they're going. And this is how fast you're going. And you multiply them together. So if you're going slow, you're going to slow the rate down when you multiply them together. All right. I was just trying to think of ways of describing that in words. Okay. But in words, that's written to the derivative of the outside function, leave the inside alone, and then multiply the derivative of the inside function. That's the chain rule. Velocity and position. Velocity is just derivative of the position. The mean value theorem. That's where the derivative, where the average rate of change over some interval is equal, because the average rate of change is equal to the derivative at some point. Okay, and then we're at some other fingerprints. We didn't talk about those. Okay. New material, implicit differentiation. So what's implicit differentiation? So explicit, the word explicit. Does anyone know what that means? If I told you that I don't want to tell you my age, but let's just say I told you exactly what my age was. My age is 6. That would be explicit, right? Implicit is when you don't say it explicitly. You say something like, I'm older than 5, but I'm less than 7. So what's my age? So I'm not telling you explicitly what it is, but you can figure it out, right? So in explicit differentiation is when you have something like function equals x squared, you can figure out what that derivative is. Because it's explicit, f of x. Implicit is when you have an equation like this, where your function is not written explicitly. You have a y squared. So if you take that function and you square it, multiply it by 3, and add 2x squared and get 45, then that's the equation you have. And now let's just see what that looks like. By the way, let me get rid of this for a second. You go. Thank you. All right. So let's just take a look at what that. So this is an equation. It's not a function. It's an equation. When I graph it, it looks like this. It doesn't look like the green and the red line. Let's get rid of those. That's what it looks like. It looks almost like a circle, but it's actually an ellipse. Okay, is that a function? Does it pass the vertical line test? No, it's not a function. It doesn't have a tangent line. Could I draw a line tangent to it? Well, sure enough, I could, because I just made one go away. Where was it? What's that tangent line? This one. There's a tangent line, and it's tangent at this point. This point is 3, -3. But you can't just say tangent at 3. Because you know what? This point up here, right up here, is also 3, but it's a different y value. And the tangent's different value. Okay, that was the other one that I turned off. Let me see. This one. Okay, those are both tangent at x equals 3. But one is tangent at x equals 3, y equals 3, and the other one's tangent at x equals 3, y equals -3. Okay, so they're two different locations. So you can have a tangent function, you can have the equation of a tangent line, and it happens at a specific x and y value. In other words, you need more information than just x equals, but you could certainly have a point. So that's what happens here. It says, okay, find the tangent line at the point 3, 3. So they have to tell you the x and the y value. So looking at this graph, what do you think the tangent line is going to be? Is it the red line or the blue line that's at the point 3, 3? Red or blue? Red or blue? No, that's 3 -3. Red, 3, 3. So is it going to be positive or negative? Is that slope going to be positive or negative? Slope of the tangent line, maybe it's going to be negative. Okay, so how do we find the derivative? So we can't just say, oh, the derivative is this. So what we do is we have an equation. We're going to use the procedure that we're going to use is first thing we're going to do is take the derivative of both sides of the equation. Okay, so we're going to take this equation. Okay. And we're just going to take the derivative of both sides. So we'll take the derivative of this, take the derivative of this whole side, which means I'm taking the derivative of that, and I'm taking the derivative of that. Okay? What's the derivative of 2x squared? Anyone? 4x. What's the derivative of 45? Skipping the middle one. So what's the derivative of 3y squared? Now, you would say 6y, right? Except y and x are, remember I said if they have different variables, you have to use the chain rule. Y is inside this function. So y is an inside function. So when you say the derivative with respect to x, you're going to bring that 2 down, the 2 times the 3, and that'll give you 6. You're going to subtract the power, y to the first power, and then you have to take the derivative of the inside. The derivative of the inside is dy dx. Okay? So when you have that equation and you implicitly differentiate, you take the derivative of both sides, you end up with 4x plus 6y dy dx equals 0. Okay, you have to have the dy dx, otherwise you got nothing to solve. When you plug in 3 and 3 for x and y, you have nothing to solve for, and it won't be true. Okay. So now, if I plug in 3 and 3 into that equation, oh, here it just says solve for dy dx. This is just algebra. You get y prime or dy dx equals that. And you plug 3 in, it just means you're plugging 3 in for x and 3 in for y, and you're getting 2/3. The whole thing becomes 2/3. So the slope of that red line is 2/3. Okay. And there it is written as a line at the 0.33. And this one right here is the other line at the 0.3 minus 3. Okay. Any questions so far? Are we good with that? You have a bunch of homework questions that have to do with, are they? I've lost them. Let me just pull them up this way again. Your homework questions, you have a whole bunch of them. So you have one just like that we just did, but you also have ones that are a little more complicated. And I just want to show you when you do the power rule for 2y squared, that's fine. But when you do the square root of xy, that's xy to the 1/2. When you do the power rule and you bring the 1/2 down, you get 1/2 and you leave the inside alone, and then you do the minus 1/2, and then you take the derivative of the inside. The derivative of the inside is a product rule. Okay, so it's the first times the derivative of the second plus the second times the derivative of the first. So there are all types of layers of rules that could be in here. Okay. All right, I'm just letting you know. This one right here, you want to get the y the other side, and there's going to be power and all types of rules. Question 4 isn't so terrible. Okay, and then that's that. All right, back to my agenda, which is here. All right, moving on to the next thing. Any questions on that so far? Tangent lines could be of non-functions. Implicit differentiation is how we find the derivative. All right, hyperbolic functions. I wish they hadn't left the room because it's a whole different thing and I'm not going to spend a lot of time on it. Hyperbolic functions are called hyperbolic trig functions or hyperbolic sine. Remember sine, cosine, tangent, and all of those? Yes, now there's hyperbolic sine. Hyperbolic sine is called sinh, and it's written this way. S-I-N-H parentheses X. You never say sine H. You can say sinh or you can say hyperbolic sine. You cannot say sine H. Okay. Sometimes students want to ignore the H. Sometimes they want to, but anyway, it's there. It's defined to be this right here. That's the definition of it. Y equals e to the, and this is what it looks like if you want to know. Hold on. It looks like that. Doesn't look anything, where it's here. It doesn't look anything like, oh gosh, do you see that? That's what the hyperbolic sine looks like. It doesn't look anything like the sine. Nothing has nothing to do with the sine. It has to do with e to the x, e to the minus x, and averaged out. Okay, or minus e to the minus. That's the hyperbolic sine. Okay. The hyperbolic cosine looks like this. It's like a big old parabola. Okay. Has anyone ever heard of the St. Louis Arch? Have you really, Pamela? You've heard of it?
Yes, I've definitely heard of it.
You've been to it?
No, not yet.
This is the St. Louis Arch. It's in St. Louis. Looks like an arch. It's along the river. It's along what river? The Mississippi? I think so. Looks like that. See it? Big arch. I don't know how tall is this elevator or something you can go into the top. Okay. It's like the Eiffel Tower of St. Louis. Okay. Anyway, this is that little thing that looks like a parabola. See how it's kind of flat at the top? It's actually hyperbolic cosine. Whoop-de-doo. Actually, it does. I think it has applications in space too, like the way when a planet, you know how when a spaceship uses a planet to go to ricochet off? That's what that is. I'm not going to say any more of that. So they have hyperbolic sine, hyperbolic cosine, they have hyperbolic tangent, hyperbolic secant, hyperbolic cosecant. They have inverse hyperbolics also, which have a little minus on them. All I need you to know is this line right here. The derivative of hyperbolic cosine is hyperbolic sine. Derivative of hyperbolic sine is hyperbolic cosine. It doesn't change sign. Derivative of sinh, the derivative of cosh. The derivative of cosh is sinh, the derivative of sinh is cosh. Okay? Are we good? Just put that in your list of many things you have to know. I already starred them before. When I gave you the list of transcendentals, I said you need to know them. So now you need to know you know them. If you look on the homework, by the way, where's the homework? It's the last question. This is a function of hyperbolic sine squared. So you're going to do it like, you're going to bring the power down. You have to remember this power, but when you go to take the derivative of hyperbolic sine, it will be hyperbolic cosine. All right, fine. Any questions? Are we good? Let me get rid of this. This one. Okay, next thing, Newton's method. It's another application of derivatives. And it's a lot to do, but let me finish it off in a very quick way. So Newton's method is used for Newton's method is used to find the zero of a function. Okay, so what you'll see for homework is they'll say, find the zero of this function. Let me see if I can pull up that homework problem again. No. Here it is. So here's what you'll see for Newton's method. Use Newton's method to approximate the cubed root of 11. Use Newton's method to approximate, find the root. That means the zero of this. In other words, solve that equation. Okay. So if I graph this equation, it looks like that. So you see right here is where the zero is, minus 3.22069. So here's the thing about Desmos, is Desmos is now giving you 5 decimal places. When I taught this last semester, it only gave 3 decimal places. Now it gives you 5 decimal places. In the future, it'll probably give you 6 decimal places. Anyway, Newton's method is a way of getting more decimal places. Okay, and here's what they do. So like this, of course, if you want the cube root of 11, there it is, how many decimal places you want. But anytime you want to find the zero, this is the process that's going on here. Hold on, I want to see if I can show you a picture from my notes. Okay, so Newton's method. So you're trying to solve an equation like x squared minus 4 equals 0. By the way, you can solve any equation using Newton's method, because if you have a function equals another function, you just move everything to one side and it's equal to 0. Okay. But this is what you end up doing. Here's how it works. Let's see. You have a function like x squared minus 4, and you guess at an answer. You say, well, I think -1 is an answer. And then you drew a tangent line. Remember, tangent line is you've got the slope and a point, but you can use the derivative to find the slope. Okay. And then what you're doing is you look for. So here's the tangent line. What you're looking for is that point right there. That's called the y-intercept of the tangent line. Okay. And then that's going to be your next guess. So then you're gonna guess that, you're gonna look for the tangent line of that point right there. So you're going up to the tangent line and then you're gonna find the x-intercept, but you see now the x-intercept is really close to the 0. And the more often you do this, the closer you get to the answer. Okay, so what does it look like? So if you find the equation of the tangent line, it looks like that. Okay, when you set it equal to 0 to find the x-intercept, the y is 0, and there's only one thing to solve for, is that x. So when you solve for x, you get x equals whatever the x value was that you were guessing, minus the function evaluated at that 0 divided by the derivative evaluated. So that's just algebra that I got to that. So now that's going to give me, when you plug in x1, then I plug in x1, and then I'm going to repeat the process, and I'm going to plug in x1 for all those things, and I'll get x2. And I'm just going to keep doing that. So what does that look like on our notes? Hold on. That's a hard problem. Where's my notes? Right. So what it looks like is it's going to be take the guess, put the function you're looking for, evaluated at the guess, and then take the derivative of that. Okay. So let me show you what that looks like. So if I have some function, what function was I looking for? Here's my function. So I'm going to call that it's z1. Okay. So if I want to know, I'm going to start with the guess. So let me graph it for a second. My graph is, well, here, my answer is something like minus 2.4. So I'm going to take minus 2.4. And I'm going to subtract the function z1, evaluated at minus 2.4, divided by z prime. That's the derivative, it's application of derivative, 2.4. Okay, and now I get 11.61. Wow, that's really far off. Minus 2 minus z of 200. But that shouldn't be that far off. My answer is right here, minus 2.4. Huh. Well, anyway, what I would do is I would take this 11. There's just no way that can be the answer.
I think, is it not Z1? Is it Z1 prime?
There's a Z in here on the right, Z1. Thank you. I just saw that when you're saying there. Now it's 2 points. See, it's close. So now what I'm going to do is I'm going to take this. This is your computer programmers. This is what it does. It takes that number and it puts it replaces all of these with that number. Boop. 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 And you see how I got even closer? 2.43633053221. 2.425988888. So now I'm going to do it again. Don't worry, you're not going to do it this way. There's an easier way. I'm going to take that number that we got from the last one, and I'm going to put that instead. Copy. Paste. Paste. Okay, so you see how the numbers haven't changed much? 4259888, 0.42598887. Okay, but they're all basically 4.259888. So I would say we can do it. We can keep doing it again till we get an answer that doesn't change. But you know, another way to do it is to just create a function that looks like this. And then I plug in minus 2.42, and you see how it gives me the same answer that I got here. Let me just bring it up here. I can just create a function that gives me the same. What you see, let me see. Here. See how they give you the same answer? So I can either type in minus 2.4 into this formula, or I can create a formula that does that. So this formula, z of whatever, let me move it up here. Z, it just says put minus 2.4 in all of those things. Okay, and then remember I said about assembly lines, then you're gonna take that number minus one, and you're gonna plug it back into this Z. So instead of doing all of that, I can just ask for Z twice. I can go Z into Z, so I can say plug it into Z and then plug it into Z, 2.4. Okay, do you see how they're the same? So instead of having to copy and paste all of these things, I just have to add more Z's. And I can add a lot of them, and it doesn't cost me anything. There's a whole bunch of them. So that's my answer. 2.425988875. So it's 888. Okay. And that's the faster way of doing it. Honestly, I used to love this Newton's method. It used to be the best. But the reason why I don't love it so much anymore is because everything, it's just going to be something you're going to get. It was a great application in its day. We used to use it to cheat the program, like when I used to use a different program. We used to cheat the programmers by finding out the answer to like 6 or 7 decimal places in the program. Would take, some programs will say find the exact answer, and the answer is square root of 2. But if you put in 1.4, and if you actually put it into 6 decimal places, the program would take it. It would be like, okay, that's the right answer. So it was a way of getting a numerical answer from and tricking a program. Okay, can we break up into our groups now? I'm done talking about those applications. We'll spend more time on them next time. I will say one thing about the square root, or did we? Yeah, the square root, you can solve square root problems too by setting up an equation, but I don't care about that. All right, let's get to our group work. Okay, so I'm going to create our, do you know what you're doing in your group work? Anybody?
Sir, professor or producer is not here.
I hope he left you something to produce.
No.
Then you have to start all over again. I'm going to tell you guys to do this. Save your, you should save your link. Cody, there he is. He never saved the link anywhere. So you're screwed. You have to start all over again. Where's the link? Is there a link? Is this a link? No. If you save the Desmos link, you have it. Even if you saved it in an earlier thing. I thought, Jonathan, did you save it in one of the earlier mods, like mod?
That was last semester in pre-calc. I used to save them all.
Yes, well, you should have grabbed him before he's bugged out on you. So now you're going to have to enter in all that data and start all over again.
Okay.
Data in. Yes, so if you look, I'm just looking at the first rates. If you had saved those links, you'd have once the data's in, like world population rates, whatever, nobody saved any links. Oh, well. I don't know what to tell you. Hopefully you have them. So what do you guys do from week to week? What do you do with your producer just have the link on their computer and doesn't bother sharing it?
Ours is shared on module 2. It's in that one, so you can go back to it and click on the link.
Okay, so let's take a look at yours on module 2. Lessons like 2. So that would be the limits discussion. It's in here. There it is. Yay. Just click on that. If you have saved it, you have so little to do because your data is already in there. And then all you need to do this week is transcendentals. Okay. So let me turn off. So that's a quartic. I don't want the quartic on, and it's in the introduction. So I'm just going to turn it off. There's my data, though. I'll keep the data. And I need this A1, B1. That's 20 and 150. Okay. Transcendentals. Okay, so now we're doing a sign regression. That's a sign regression. Not bad. Okay. Okay, one thing to note is, I don't know where you got this worksheet from, but it's not good. I'll tell you why. What is the period of this function here? This is a sine regression. What's the period? How long does it take to go from here at minus 141 to here, which is 382? What's 382 and 141? 520?
Yeah.
Yeah, so fix this. This should be 4. Now the period is the same, 520. Now the period is, what the heck? It work? Oh, what's the period here? Starts here. It ends there. Oh, that's 900. That's more. I don't know. Anyway, to get the period, you should really just figure it out from going from peak to peak. So just add those numbers up. So it should be 520. It's not that number, but it's twice that number. You can't just change it because that'll mess everything up because of the way this function is written here. So you would say, according to the sine regression with a period of $540,000. So this is a sine regression with a period of $540,000. Okay, this is you. So you don't want $12,000. What's the salary you want?
75 and 100.
75. Okay. These are how many best friends you have. This is how much is changing by, and it's accelerating by some super tiny amount. They're both accelerating. Okay, what you can do if you want, you change these, you can change the sine regression. Like if you want it to have a bigger period or a smaller period, you can adjust that. I think it was fine the way it was. You're not going to get to all those points. That's probably good enough. Okay, so all of you could adjust your whatever your period by changing this. By changing your A1 and B1. You don't need A1 and B1 for anything, but it will change your period. So play around with that. And then you're going to say stuff like, then you get to say stuff like, just like what you should have said before, but now you're saying it for transcendentals. You're going to say the writer is going to write this. And the speaker is going to say this, except they're going to say according to the sine regression with a period of something. You have to say the period because you can adjust the period. You need to say the period. Remember, I said when you say the regression says something, you're not saying it, the regression is saying it. But if you pick a period, but you could pick all different periods, so you have to say which one it is. Okay? All right, please, if you're a group of 3 or a small group, make sure you have a writer and a speaker. I want to see both. I want to see the production, the writing, and the speaking done. All right, let's get into it. Yes?
I don't see any harmonized link in module 4.
There will be in a few seconds. Give me a moment.
Okay.
Okay, the rooms are open up. I'm going to get to it right now. Okay, who's in what? Remember, I need to know if there's any group. Are you guys all here?
That's Lena.
But she's not here. She's not here either.
Yeah, so us 3.
It's just the 3 of you.
Yeah.
Pamela, is your group? You're all by yourself, but your group is here. Who's in your group, Pamela? What group are you in? Havani's in your group? Okay, so you're in room 4, so you have to log on. Oh, I see. You're here. And Sebastian and who's with you?
Aiden's and Eric.
Aiden and Eric?
Yeah.
Acacia is with Jonathan. Carlos is in what group? I don't know. He's with you? What room are you in? One? No, you're in room 3. Carlos is in room 3. Okay, well, I'm gonna let him join whichever group he's supposed to be in. Jonathan's all by himself in room 2. Who's joining him? Acacia.
Yes, but our producer, what are we gonna do?
Move into room 2 and talk to Jonathan. He'll have an idea. He
Okay.
knows what to do. Luke, what room are you in?
4, I believe.
Yes, you're in 4. Carlos is in room 3. And everyone's got people in their rooms. Okay, good. Why are you hovering? Stay.
I have a question.
Okay. No, shoot, I almost closed all the rooms. All right, let me do this one thing and then I will answer your question or ask your question and I will try to do them both at the same time, but.
I was gonna show you just to check, so I'll wait.
Okay, wait, hold on, then let me just build a harmonized thing. Harmonize discussion. Create new. Traits. 15. Okay. Okay, there it is. It's created. I'll clean this up later. Okay, what do we got? Show me. Show me the money.
We were talking about like you were showing this number and talking about that. What were you saying about that? Like, do I need to?
You need to
I made it a
put your
little bit.
period in.
I made it a little bit small.
Okay, so you need to go to the top of this mountain. And that is minus 45. Go to the top of this mountain. 275, add 45 to 275, and what do you get? 280.
That's 320.
320, which is twice that. So just say, just write down that the period is 320. You
Okay.
should have mentioned, you could just write it that the period is 320. Don't mess with that one, but just write down the period is 320. And that way those guys can mention it. Whoever's saying it has that should be on there somewhere.
Okay.
The period is
And then
320.
like the rest of this is fine. Like,
That's fine.
I need that.
Yeah. Okay, perfect. Well, just take a picture of that. Get rid of the other graph. You can.
Okay.
Okay. Turn your videos on. Don't make me come in there. Sebastian, did you hear that?
Yeah. This laptop's computer or this laptop's camera's broken. So I literally do not have any power to turn my camera on. If I
You
do,
don't?
Yeah, this laptop, I bought it and it was broken and then I didn't buy the warranty for it because I thought it'd be fun.
It's okay. You can use an external if you have to for a test. But for this, it's okay. I can see you. But if you're at home, I'm going to ask you to turn it on. Okay, so you heard that? You heard me broadcast it over your earbud.
Uploaded the screenshot.
Do they have their videos on?
I'll do another.
Don't join that room and just make sure their video's on because I'll be in there if they don't.
I've been able to.
What?
Did you speak right?
Eric and Aiden do?
Yeah.
Function is. Just put on this back. To index 320, 320, just twice.
Oh, I stopped sharing. That's why this is looking crappy. There we go. Selena has joined.
Yeah, I'm here. Sorry, I had a game. I only arrived now.
Selena, okay, do you know what room you're in?
I'm with group 1, right? Business admin.
Yeah. Except they're all sitting right here. You're the only one not here.
Yeah, I'll go.
Slate's gonna join for you.
Okay, should I go to the room now?
Go into room 1. Yep. Turn your video
Okay.
on so he can remember what you looks like. And then he'll tell you what to do. She's going into there she is. I moved you. You're in room 1. He'll be in with you momentarily. Okay. Here's my stuff, man. Here it is. Okay, that's what I'm looking for. Okay. How are we doing? Sebastian, you okay? And you guys, are you okay with her? I don't hear nobody talking over there.
Yeah, I just put it in the chat and told her what to do.
Okay. What is she doing? Presenting? Is she gonna talk?
Like the speaker. She's not gonna like send a voice chat.
She's gonna
Voice
write.
is-
She's gonna
write.
be the speaker who writes.
Yeah,
As opposed to the speaker that speaks.
yeah.
What are you doing?
Writing the formula.
And
Presenting.
you're presenting, you're gonna be the speaker who speaks. Okay, fine.
Function is
I'm gonna join room 3 and see how they're doing. Okay. Are you guys done? Done?
I did my part.
Producer did your part? Okay,
did
so
part of what I
producer,
do.
what you can do is move on to mean value theorem while you have it. Go to the mean value theorem. So what you need to do, if you're done producing, you put your image up and you're happy with it.
Yeah.
So now take that sine regression off the screen and put the quartic back up.
Okay.
I just want to make sure that whatever I read is the right book.
G of that equals BFFs, G prime of that equals BFFs per $1,000. G prime of that is that times 10 to the negative or BFFs per $1,000. Good to me. Question, you guys done?
Yeah, other business posting their own parts right now.
Oh, okay, so you're the producer and he's the producer. I just need the two other producers. Let me see how Jonathan's doing. All right. Jonathan's group is not here. Jonathan and Akeisha are the only You guys are done? What's going on here? Pam? Hold on, I just. Okay, the rooms are being closed. So I can get back to this. I need to try. So you guys know that those notes that I was working from come from these links right up here where it says date. Today was day 7, right? Today should be an odd day. Then the next time I'll have day 8 up there. It's probably just going to be this mod 4 because we're still in mod 4. But anyway, that's where those notes come from. You know, there's the example worksheet is good if you want to know the other tasks that have to be done. There's a video on how to do what we're doing. Okay, that's supposed to be in there. You know, there's a video here of me going over these. I'm not sure. Some of these videos are quite hard. Damn, you're pulling me. There she is. Okay, and then these questions, they're questions. There's a couple things missing. The say it out loud thing is missing, but it'll be there soon. Okay. And it will be how to say higher order derivatives. Okay, so let me just go through this for a second. So this for the homework. So I went over implicit differentiation. Those are the first 4 questions. Okay, to do a Newton's method, you're trying to solve something equals to 0. Okay, so you'll see that what I do is I say let the function equal what that is you want to be equal to 0. If you graph it, you'll see that's the graph. You're looking for this number right here, minus 3.22069, but you need more decimal places. So to do that, it says use Newton's method. To use Newton's method, you have to either write it this way and get a new number and then plug it in again, or you could do that thing that I showed you before. You can create a z function. You can go z of x equals x minus, what is this, f1. F1 of x divided by f1 prime of x. Okay, so you can do it that way. And then you can just type in z of x, z of, what is the answer? Minus 3.2, minus 3.2. You don't even have to be close. Z of minus 3.2, why isn't it working? Need to find z. Okay, so let's try z11. Z11. Okay, so I can just do this part right here. Hold on. I'm even gonna get lazier than normal. Copy. Paste. Get rid of that. Come on. So I can just keep putting these Z11s on here. C11. Z11. Z11. And eventually I'll get the answer to so many decimal places. 3.220693, 3.220698. Or 3. Okay. So for something like the cube root of 11, Why would you even do that with Newton's method? But so if you want to do it using Newton's method, you have to change this. So if this is your answer, you cube both sides, so you get 11 equals x cubed, and then you get x cubed minus 11 is the function you want. And that's where that comes from, x cubed minus 11. And then you can do the same thing with the z thing and get the answer. But you honestly could just get the cube root of 11. But if the directions say to use, this is where people lose points. If the directions say use Newton's method, then you have to use Newton's method. And you can do it either by chugging this stuff in the way one at a time, or you can use that z thing. That works too. Okay. Here, this one says use Newton's method by hand to give the first and second one. So now you can do the z once, and you could do the z the second time. So you could do it once and the second time. If you do it once, you get 11/7. If you do it twice, you get 1.43 or whatever. Used to be it wanted it as a fraction, and that would have been a fraction. Okay. All right. So you don't need the table. All right. Question 8. Velocity and acceleration. Does everyone know that if they give you the height and they're asking you for the velocity, they're just asking you to take the derivative, and that's the derivative. And if you want to evaluate it at 9, you just plug it in. But honestly, you could just write that. If you just did h prime of 9, if you just wrote h prime of 9, it'll tell you the answer is 211. And if you want the acceleration is the second derivative, you can either do the second derivative by hand and get 26, or you can just write it down h double prime. Make sure when you do double prime on Desmos, you're doing prime, 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 prime. Don't use the double quote thing. It won't work. Okay? All right. Check on Desmos. So, question 9 is another thing where you have a
Professor?
Yeah, don't tell me I'm not sharing.
Sorry, I had a question. I was looking at the schedule, and I see that we have a derivatives test on October 5th, which is a Saturday. I was just wondering how that's going to be structured.
Okay, hold on. I'm almost done with this, and I'll answer that question.
Okay.
10 is a fourth derivative. 11 is a derivative. Remember, the only thing you have to remember about this one is that that's hyperbolic sine squared. So this is just a chain rule. It's just a chain rule like this. But it has a hyperbolic sign in it. So you're going to take the derivative, you bring the 2 down, and so this is a chain rule. Actually, this chain rule is done twice. But when you take the derivative of hyperbolic sine, you're going to get hyperbolic cosine. All right. Fourth derivative we'll do next time. So in answer to the question, do you have a derivative test coming up? Why, you certainly do. Okay. So at the end of this, you have a quiz, quiz 4. It's not listed here, but quiz 4 should be showing up soon. So the test, the derivatives test, is going to be on next week. It's the end of next week. It's on the syllabus. No, it's on the lessons mod 0. Okay, so it says right here, derivatives test is 10-5. So now, how many questions are there going to be? There are going to be 15 questions. Okay, we're doing 4 mods, 1 through 4. So this mod we're doing today is the end of the derivatives test. Okay, there will be 4 mods on it. There'll be 3 questions of each type. So there'll be 3 vocabulary questions like, what is math? Math is a language, thank you. And then there'll be 3 questions like that. Then there will be 3 more questions that are going to be like, say this derivative out loud, say this limit out loud, say this something else out loud. So we've got 3 things to say out loud. And then the next thing you have is 3 things that are going to be like, what happened between lines, what, and balloons lines 7 and 8. Actually, I think for the derivatives test, it just has the pictures of the lines, not a whole sheet you have to click on. It's like, what happened here? And you have to say, was it a chain rule, a product rule, quotient rule? Check all that apply. It's not multiple choice, but it's check all that apply. So if it's chain and power, you have to click chain and power. If you only click chain and not power, you could lose points. You definitely will lose points. Okay, and if you say chain and power and quotient and it's only chain and power, you also lose points for saying too many things. So be careful about those. There's 3 more questions which are like solve this. And so I would guess those solves are going to be something that's pretty important, but wasn't done on the discussions. The discussions were the limit, finding a limit, that'll be a discussion thing. Finding a derivative and a second derivative and talking about it, that will be a discussion thing. So that'll be in the last group of questions. But there are some things I can't ask you, like epsilon delta definition or whatever. Whatever's on the quiz that I can't ask you as a discussion, I will put on as a report. So there's 3 of each type. And honestly, the first 2 and the first 6 and the last 3 are usually pretty easy. So it's just the middle, it's just those, so do the equation stuff. So while you're freaking out about derivatives, there aren't that many questions about derivatives. I mean, there are questions about derivatives, just aren't many calculate derivatives. There are more on the midterm. The midterm is like 20 questions, 4 of each type. About what?
So you put the test on Saturday?
Yeah, why not?
We got a job.
So, all day? You want to take it Friday?
Yeah.
I don't think it's on Saturday. It's the 5th.
Yeah, it's Saturday.
That's so weird. The other class is the 4th. 4th then. Okay, take it on the 4th, just to remind me.
You work on the 4th.
I can put it on the 3rd. You want it on the 3rd? It's already wrote it, so it's. Okay, but that's a Thursday.
I mean,
Anyway, you know it's all day. You work all day from morning to night? How would you really, where do you work? I'm coming to your job. You're not there. What time?
And, I'm sorry, 12 10, sorry.
12 to 10? So you have all morning.
yeah, 10-hour shift.
You have all morning and what? That's it. You have up till 12, till 10. But how long does it take you to get ready? 2 hours?
No.
This test should really only take you about, I believe you have an hour and 20 minutes to take it. But I think it should only take you about 40 minutes to take it. It's not that long a test.
Is the derivatives test going to be proctored by HonorLock, or is it going to be on Black?
On HonorLock. Yeah, it's on HonorLock. And the first question, and you have to speak, the first 6 questions are all spoken. Spoke. So you're not writing anything for the first questions. And then the next 3 are multiple choice, I think. And then the last 3 may also be spoken. I'm not sure yet.
And how many questions did you say there was on it?
15.
Got it.
So there's a lot of talking. And again, I will take points off if you take too long to answer questions. So make sure you can answer those vocabularies quickly and read them quickly. The longer you take, the more impatient I get because I have to watch them. It's nothing to do with, yeah, if you take a long time, but if you're thinking out loud or whatever, that's less boring. But if you're just staring at the screen trying to think of something, then probably gonna lose some points. Or a point. I don't know, I haven't done it yet. But it's like a job interview. Don't mess up a job interview. Consider it like a job interview. But it's a small, the whole point of this first test is for you to get HonorLock to work and to figure out how the test is going to be administered, and just understand that the midterm and final are just more questions. They're the same, and they come from the quizzes mostly. So I don't know if they're horrible, but they're very different. They are not, I do not choose them, the program does. So you may get a whole bunch of different questions. Everyone's getting sort of different questions, but they mostly come from the quizzes. So you should have seen them before, or you might have seen them before from the quizzes. Okay? We'll just figure if it's, and it's worth 10%, it's honestly not worth very much. To tell you the truth, if I was calling this something, I would just call it a quiz. I call it a test because it sounds more weight, but the midterm and the final, those are tests. But the derivatives test, that's just a big quiz. And the quizzes that you take, those are just graded homework. That prepare you for the quizzes, that they're not useless. They're not worth very much, but they prepare you for these big tests, for the big test. The big test is the midterm and the final. Those are worth the most. The midterm and the final are 55% of your grade. Okay. And if there's, those are the ones you have to do them. That they have to be clean. That's why I want you to do honor lock. When you take honor lock and I see all the horrible things I'm going to say on honor lock, I will tell you. And if I don't tell you, and you don't wait till the final to screw them up. Because I don't have another test, I just have the midterm and those are the 3 honor lock tests, derivatives, midterm, final. Okay? But you have a project that might also be on honor lock, I'm not sure. So I think I'm going to honor lock or harmonize, because you have to present it. You have to sound smart. Okay, that's enough. It's 7:58. You're all free to go. Have a nice day. I took attendance already, so I'm free to log
Thank you.
off. Anybody?
Thank you, teacher.
Take care, Christian. Thanks for coming. Hey, thank you. No problem.
Thank you.
Thanks, Professor.
Okay, how do I turn off Cam? How do I turn off